yesterday we did 7.3, well, we started 7.3, which is solving trig functions. We said that we're going to isolate the trig function. We're going to then locate the solution on the unit circle and give all the possible angle values. And if our instructions say on the interval of 0 to 2 pi, we're done at that point. We talked a little bit about the bottom, like what does that mean? But we're going to do a couple more examples with the bottom part today, which is if it didn't give you the interval, if it just said to solve, you would have to find the coterminal angles. You don't have to find the specific ones, but you literally just add 2n pi to the ones you find if it's sine and cosine or secant and cosecant. And for tangent, that repeats every half circle, which would be just 1 pi. So you would add n pi to that. So we're going to talk about what that looks like in a couple of examples. Yep.
What is
n? N just represents a constant. So you leave n in your answer, but technically n could be any constant. So it could be 1, which means not only does that answer work, but 1 pi more or 2 pi more than that also works. Or 4 pi or 6 pi. If you kept finding coterminal angles, those answers would be the same. All right, so I said to do 8. We skipped 8 yesterday. We're going to factor this. If I keep the sign, and you don't have to, you can also plug in your a. If I keep the sign and do trial and error, then I would get -1 and -1 here, and that's going to give me the -3. If you could have also done first times last. So a couple different ways to do this. But once you get to here, you want to split and solve this. So on the left, you'd get 2 sine of x equals 1, and then sine of x would equal 1/2. And on the right, you'd get sine of x equals 1. And then you'd go to your unit circle, and you'd locate the sine is the y coordinate. So you're looking for where y is a positive 1/2, which happens at pi over 6 and 5 pi over 6. And where y is 1, which happens at pi over 2. So my solutions would be pi over 6, pi over 2, and 5 pi over 6. On an open-ended question, order doesn't matter there, obviously, okay? But on a multiple choice, it usually will put it in order like that. So let's say it didn't say on the interval of 0 to 2 pi. So this would be if it gave that instruction, 0 to 2 pi. And then let's say it just said solve and it didn't give the interval. No interval. If the instructions don't give the interval, then your answer has to have the interval. So this means use just what you see, your natural unit circle, everything that's here. This means that plus all the coterminal angles. So I would take my answers from here, pi over 6, and I would add 2n pi, pi over 2 plus 2n pi, and 5 pi over 6 plus 2n pi. So that's the difference between those types of instructions. Hang on 2 seconds. The other thing that you might see is if the interval was 0 to 360 degrees. What does that tell you? So we don't have to convert, but we want to grab the angle at that point that's in degrees. So if it would be the same angle, but it would be the one that's in degrees, which would be 30, 150, and 90. So those answers, that's how that would differ. So you want to kind of pay attention to instructions. If you look up a lot of CUDA extra practice, we'll give it to you in degrees, and you would just need to know that that means the same thing. So if there's a question on the test that says from 0 to 360, it wants the answer in degrees. Does that make sense? Yes? Without the interval in the instructions, you'll give it in radians with the 2 pi n. But if it gave you the interval is either going to be 0 to 2 pi and you know to give the radians, or it's going to be in 0 to 360 and you'll know to give the degrees.
What is n equal?
N is a constant. So n stays as n. It could be 1, it could be 2, it could be 3, it could be 4. It means you're going around the circle 1 more time, 2 more times, 3 more times, or less. -1, -2, -3. It's just coterminal. So n stays there. You'll also see k written there. It's the same thing. It just represents a constant.
Why would it not be plus or minus?
Because the n could be negative.
Oh,
So that's how it makes it negative. Does that make sense?
Mm-hmm.
Yeah. Okay. Then we did these and we left off here. Directions say solve on the interval of 0 to 2 pi. Do you got to figure it out or no? Yeah. You're just going to have to write something else. All right. So again, it says solve on the interval, and then it says check for extraneous roots. So these you're going to definitely have to check, okay, and make sure that you can use the answers that you get. So first of all, if I look at these two, notice the difference of this that hasn't happened yet, and that is that there's two different trig functions in the statements. I cannot factor one out, and neither of them are squared, so I can't replace them as they are. What hopefully you notice is that sine and cosine are linked through Pythagorean theorems, like hopefully, or identities. Hopefully we remember that by now. Sine and cosine would be linked, tangent and secant would be linked, and cosecant and cotangent would be linked through Pythagorean identities. So if I could just get this to be squared, I could replace one with the other. If I could just square sine, I could replace it with 1 minus cosine. So that's what we're going to do. We're going to square both sides of the equation. Whatever you do to one side, you got to do to the other. So I'm going to square both sides of this equation. On the left, I am not going to distribute that exponent because that is not how I square a sum or difference. I either have to expand and FOIL, or I have to use the shortcut. So if we expand and FOIL, it'd be cosine x plus 1 and cosine x plus 1. And I do cosine times cosine, which is cosine squared. Cosine times 1, which is cosine. 1 times cosine, which is cosine. And 1 times 1, which is 1. And I'd get cosine squared x plus 2 cosine x plus 1. And then we're going to square the right side, and I get sine squared x. So the shortcut for a sum or difference squared is you square the first term, you square the last term, you double the product. So it would be 2 cosine x. You're going to do this at least a couple of times in tonight's homework, so it's useful to remember that shortcut. If you don't remember it, you just expand and FOIL, like we did. Okay, so now I need to get them to be the same, right? There's a cosine to the first and a cosine squared, so I don't want to replace the cosine. The sine is what I want to replace. Because sine squared plus cosine squared.
It's negative cosine squared plus 1?
I would do the other way around. I would subtract the cosine, but you're not wrong. It just makes it a negative cosine. Yeah. So, no, you didn't. You said negative cosine plus 1, right? 1 minus cosine squared I just think is easier. It's the same thing, okay? So I get cosine squared x plus 2 cosine x plus 1 equals 1 minus cosine squared x. Now they're all the same, so I want to get them all to the same side. I'm going to add the cosine squared x, and I get 2 cosine squared x plus 2 cosine x plus 1 equals, oh, the 1's still there. So then I would subtract the 1, and I get 2 cosine squared x plus 2 cosine x equals 0. Yep. Well, you could factor it out, or you could divide by it, sure. Yeah. So I want to actually eventually take out the cosine. I tend to do both in the same step, but you could do them separately. I could take out a 2 cosine, and I'd get cosine x plus 1. And now I can split and solve. So on the left-hand side, if you divide by 2, it's going to go away, and I get cosine of x equals 0. And on the right-hand side, I'm going to subtract the 1. Joey.
We're going to have to do Pythagorean theorem with these. I mean, sorry.
Quadratic.
Yeah.
Yeah, we're going to do that in a little bit. Just for fun.
Where did the plus 1 come from?
The plus 1, from which one?
Cosine x plus 1 in parentheses.
I factored out 2 cosine. So 2 cosine divided by 2 cosine is 1.
Oh, because that one's squared.
Yeah. Okay, so now I'm going to my unit circle, and I'm looking for where cosine, which is the x, is 0, which is at 0 and pi. And I'm looking for where cosine of x is negative 1. Wait, sorry, just kidding. Cosine is the x, which happens at 0 pi over 2, and 3 pi over 2. It's pi over 2. 0 is, cosine is negative 1 at pi, and 3 pi over 2. Okay, so here's the catch when we square both sides of the equation. If you can remember back to like even when we did this with square roots, if we squared both sides of the equation, we had to check for extraneous roots because you're bringing in a root that might actually not work. So when you square both sides of the equation, you have to check your answers. It's also not awful to learn how to check your answers here because if you had extra time, you could do this with every question. So I'm going to check these answers in my initial equation. I'm going to get cosine of pi over 2 plus 1 equals sine of pi over 2. Then I'm going to check cosine of pi plus 1 equals sine of pi. And then I'm going to check cosine 3 pi over 2 plus 1 equals sine 3 pi over 2. So still using my unit circle, what's the cosine at pi over 2?
1 and a 0 side.
0, right? Because it's the x value at pi over 2. Plus 1 equals, what's the sine at pi over 2?
1.
1, because it's the y. So this one works. Then I go to the next one. Cosine at pi, so the x at pi is negative 1, plus 1, equals the sine at pi, which is 0. And I get 0 equals 0, so this one works. Still good? Yep. Cosine at 3 pi over 2 is the x there, which is 0. Sine at 3 pi over 2 is the y there, which is negative 1. Does 1 equal negative 1? No. So this one does not work, and my extraneous root, which is 3 pi over 2, gets ruled out. Yep.
Are we going to do that every time for this exercise?
Every time you square both sides. Yes. Yeah. You don't do that a lot, but every time you do have to check them.
Oh, I don't understand.
Huh?
How do you...
Process for 12. Okay, 2 different trig functions, can't factor anything out, nothing squared, so I'm going to square both sides of the equation. So shortcut on the left, square the first one.
Can you do that if they don't, and then, like, if they're not over 2? Like, if they're over 4, do you do the same thing?
Yeah. Square the last one.
Go back slightly.
Hang on. Double the product here, and it's 2 sine x. And then the right side would be cosine squared x. Okay, now we want to replace, and this time I want to replace the cosine. If sine squared plus cosine squared equals 1, then cosine squared equals 1 minus sine squared. So sine squared x plus 2 sine x plus 1 would equal 1 minus sine squared x. I'm going to add the sine squared x. And I'm going to subtract the 1. I'm going to do them both in the same step this time. 2 sine squared x plus 2 sine of x equals 0. I lost my s. There. Same as before, factor out a 2 sine. So this is basically the same question, just reversing the sine and cosine. And I get sine plus 1 equals 0. And then split and solve. So sine of x equals 0. And sine of x equals negative 1. Now I want my sine to be what I look at. So I'm not looking at the x, I'm now looking at the y values on my unit circle. The y is 0 at 0 and pi. And the sine is negative 1 at? Good, 3 pi over 2. And then because we squared both sides of the equation, we have to check them. So sine of 0 plus 1 equals cosine of 0 is the first thing I'm going to check. Then sine of pi plus 1 equals cosine of pi. Then sine of 3 pi over 2 plus 1 equals cosine of 3 pi over 2. Sine at 0 is 0. Cosine at 0 is 1. So that one works. Sine at pi is 0. Cosine at pi is negative 1. That one does not work. Sine at 3 pi over 2 is negative 1. Cosine at 3 pi over 2 is 0. So that one works. So I get to keep 0 and 3 pi over 2, but I eliminate pi. All right, 13 and 14, and I think the next one's, nope, that's different. 13 and 14, okay, are something called multiple angle equations, okay? And it won't, sometimes it will tell you, so we're gonna call them multiple angle just so you know what they are, multiple angle ones. Sometimes it will tell you what to do with these. It'll say like solve the multiple angle equations, and sometimes it won't, and you have to identify that they're different. Now, the way we identify that they're different is there is a number being multiplied or divided by, because it could also be divided by, the variable. So you notice there's something in between cosine and t, and there's something in between sine and t, okay? It might also look like cosine of x over 3 equals 0. It could also look like that. So if you are multiplying or dividing by something next to the angle, then the end of this changes. It adds a step, okay? Because instead of solving for x like we've been doing, we actually are solving for 3x or 3t, and so that there's one more step. So until we get there, it's exactly the same. I'm going to ignore that 3t until I get all the way to the end. So if I was to do that, the first thing I would do is add 1, just like regular. 2 cosine 3t would equal 1. Then I would divide by 2. And I would get cosine of 3t equals 1/2. Now I cannot divide by 3 here. 3 is protected by that cosine. 3t is a partner. It cannot be separated until I get rid of cosine. It's not like the square where we can square root it, okay? So what I have to do first is figure out where is cosine 1/2. And then I would set that angle equal to 3t. So think about your unit circle.
It's under 3 over 3.
You flip it?
No, multiply by secant, which is 1 over cosine.
Yeah, but then your secant's going the other side and you're finding the secant of 1/2. You can't do that.
Pi 3 and 2 pi over 3.
So it is, sorry, I didn't hear what you said.
Pi 3 and 2.
It is pi over 3 and cosine, where else is cosine positive?
2 pi over 3.
Nope.
Oh, the 5 pi.
Good, 5 pi over 3. So my two angles are pi over 3 and 5 pi over 3. Okay, so the two answers are pi over 3 and 5 pi over 3. And because it doesn't give the interval in my instructions, it would have just said solve. I have to add 2n pi because it's cosine. So I'm going to take pi over 3 and add 2n pi, and I'm going to take 5 pi over 3 and add 2n pi. And if the question just had one variable, I'd be done. It would be t equals that, but it's not. It's 3t equals that. So the last thing I have to do is divide everything by 3. Or multiply by a third. This is pi over 9 plus 2n pi over 3. And then divide everything here by 3, and I'd get t equals 5 pi over 9 plus 2n pi over 3. So those are your two answers, okay? Yeah. What's weird about these is that it's not just happening every 2 pi, it's happening every 2/3 pi. So these get super confusing if you don't have the interval. Like if it didn't say this, these are even rougher, which you're going to get in pre-calc. You'll go back to that next year. I'm hoping not to have to do that. If they're on the test, we'll go back over it. But because now you actually have to find the specific answers on your unit circle by using that changed interval. So if that happens, we'll go back over it tomorrow. For right now, we're not going to worry about it. Yeah.
Thank you.
You're welcome.
What happened to the cosine and the half again? The last red
We
line.
found where cosine is 1/2.
So we can
What do you mean on different sides? Well, that would just be like if it said cosine of t equals 1/2, right? That was like every other question we had.
Oh.
The difference is now there's one more step after because there's a number in between. Yeah.
What is the cosine x over 3 equals 0?
Oh, that was just like also it could be divided by. So it could be, that's also a multiple angle. That's another question,
Oh.
right? Because it could be like we're doing multiplication here. If it's being multiplied by that variable, it's a multiple angle one, which is these weird ones. But also if it was divided by,
You just multiply them all.
at the end you would multiply instead of dividing.
Okay.
Yep, so you would find where cosine is 0, which is at pi over 2 and 3 pi over 2,
Yeah.
plus 2n pi, and then at the end you'd multiply it by 3.
Okay. And then for these are the answers.
The highlighted ones, pi over 9 plus 2n pi, and 5 pi over 9 plus 2n pi.
Okay. Thank you.
You're welcome. All right, weird, but we're going to do it again. Okay, hopefully it gets a little bit easier. So again, they're going to get mixed in. So you got to be able to spot it. And I spot it by seeing that t is not by itself. It's got something multiplied by it. All right, so the first thing I'm going to do is add the root 3. 2 sine 2t equals root 3. Then I'm going to divide both sides by 2. And I get sine of 2t equals square root 3 over 2. Now I go to my unit circle. And I find everywhere sine, which is the y, is root 3 over 2, which is where? Pi over 3, 2 pi over 3. Plus 2n pi plus 2n pi. And again, if it was just t, that would be my answer, but it's not. It is 2t equals that. So I'd have to divide everything by 2 or multiply by 1/2. And I get pi over 6 plus n pi. And over here, divide by 2 or multiply by 1/2. And I get pi over 3 plus n pi. So you want to add the interval on first before you divide by what's next to the t, or if you had to multiply by what's next to the t, then you would want to do that after. If it was tangent, so let's say it said tan of x over 2 equals 0, okay? Let's say we already solved and we got to that part. Where is tangent 0? And
1.
pi. So I would say x over 2 equals 0 plus n pi, and x over 2 equals pi plus n pi. And then this time you divided, so you want to multiply everything by 2 at the end. I'd get x equals 0 times 2, which is still 0, plus 2n pi. And multiply by 2 here, and I'd get x equals 2 pi plus 2n pi. So these are actually like repeating the same thing. Most standardized tests will ignore the second one because 0 plus 2n pi is 2n pi. It's not that it's wrong. It's just a duplicate answer. Bella.
We could still get undefined for questions.
Yeah, sure. God bless you. There's one like this. So this looks like the other ones, right? Because it looks like I should be able to factor it. But are there factors of -2 that sum to -3? No. So when we can't factor, we do the quadratic formula. So what I would strongly recommend probably to ease the confusion is change that to your a. So a squared minus 3a minus 2. So our a is sine of x. And we go quadratic formula, -b plus and minus the square root of b squared minus 4ac all over 2a.
Are we going to have to see this one?
So a is 1, because it's what's in front of the squared term. B is -3, and c is -2. And I get +3, because that's the opposite of -3, plus and minus the square root of -3 squared minus 4 times a times c all over 2 times a. And I get 3 plus and minus the square root of 9 plus 8 over 2. 3 plus and minus the square root of 17 over 2. And that is what sine of x equals. So sine of x equals 3 minus root 17 over 2, and sine of x equals 3 plus square root 17 over 2.
Is this the one we use a calculator to
So think about it first. Like if you obviously if you didn't have a calculator, I would try to approximate that. Square root 17 is about what? 4. So let's like a 4.1, 4.2, right? If you do 3 minus that divided by 2, do you get a decimal is the question. If you get something bigger than 1, then you can't do it with or without a calculator, okay? If you want to type it in your calculator, you'd get, oh, I just on the wrong screen. 3 minus square root 17. Either put it in parentheses or hit enter and then divide by 2. And I get negative 0.56. And then 3 plus square root 17 divided by 2. And I get sine of x equals 3.56. That one cannot happen. That's an extraneous root. You cannot find the inverse of like sine can't be bigger than 1.
So do we just leave it in decimal?
No, I'm still trying to find that angle, right? That's just the sine.
Oh, do we use sine -1?
Except what it happens when it's a negative angle. Do you remember?
Yeah. We just put it normally.
You put it positive, and then you have to find where sine is negative. So we go back to, all students take calculus, where would sine be negative? 3 and 4. So I'm going to do sine -1 of positive 0.56 to get the reference angle. I'm going to make sure I'm in radians too, because these are in radians. And I get my reference angle would be 0.59. But that is not the answer because that's going to give me a positive sign. I have to go third quadrant, 3.14 plus that. Fourth quadrant, 6.28 minus that.
Is there only literally one of these in the test?
I think there's one on the homework. I don't know that you're going to have your calculator on your test, so hopefully that answers that question.
Oh, so there would be one of these if we couldn't use the calculator?
Correct. You're going to, yeah, to find out what sine would be. And then inverse it. If it was positive, I just find the inverse of it. But because it was negative, I make it positive. And then I find out the 2 quadrants where it'd be negative. And then I do it. If it was positive, I'd find the reference angle. That's still only my first quadrant. Then I'd have to find the one in the second quadrant that also works. Yep.
I don't know how to make my calculator square root 17.
So for the homework, you're going to skip number 6 because we did that in class. And then for anything that's the multiple angle one, change the instructions to just solve, not solve on the interval of 0 to 2 pi. And then it will be like we did the examples in class.